This is it, folks. This is the first of the special episodes I want to do from time to time to expand our perspective and get inspired by what's going on elsewhere. The guests will not come directly from the Bayesian world, but will still be related to science or programming. For the first episode of the kind, I had the chance to chat with Michael Kennedy. Michael is not only a very knowledgeable and respected member of the Python community, he's also the founder and host of Talk Python to Me, the most popular Python podcast. He's the founder and chief author at Talk Python Training, where he develops many Python developer online courses. And before that, Michael was a professional software trainer for over 10 years. He's taught numerous developers throughout the world. But Michael is not only an entrepreneur and teacher, he's also a father, a husband, and a proud inhabitant of Portland, Oregon. As you will hear, our conversations span a large array of topics: the role of Python in science and research, how it came to be so important in data science and why, what are Python's threats and weaknesses, and how it should evolve to not become obsolete. Michael also has interesting thoughts on the role of programming in education and how it relates to geometry, but I'll let you discover that one by yourself. This is Learning Bayesian Statistics, episode 15, recorded February 19, 2020. Welcome to Learning Bayesian Statistics, a fortnightly podcast on Bayesian inference, the methods, the project, and the people who make it possible. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country, and reach a true Bayesian state of mind by visiting learnbayesstats.anvil.app. That's learnbayesstats.anvil.app.
Let me show you how to be a good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. What's a Bayesian? It's someone who cares about evidence and doesn't jump to assumptions based on intuitions and prejudice. A Bayesian makes predictions on the best available info and adjusts the probability, cause every belief is provisional. And when I kick a flow, mostly I'm watching eyes.
Michael Kennedy, welcome to Learning Bayesian Statistics.
It's so wonderful to be here. Thanks for inviting me, Alexander.
Thank you for taking the time. It's such an honor to have you on the show. You're literally the person who taught me Python and allowed me to become a data scientist 3 years ago. So thank you.
Wow, that is so cool. You know, I really appreciate that, and congratulations on making all this progress. I mean, you went from I'm learning Python to, hey, I have a podcast, I'm a data scientist, and all these things. And it's really amazing, these small things that you do in life that you're like, oh, I'm going to do this thing, and it kind of spreads out and, you know, really benefits people in ways that you don't necessarily know. You told me now, and that's awesome, but like a lot of times people don't know the effect that they have, right?
Yeah, exactly. I noticed that with the podcast too. I mean, my reach is really not the same as yours, but I have some people told me they really love the podcast and so on. It's quite rare compared to the number of people who listen, you know, but it's always great to have some feedback because most of the people, well, don't take the time to give you feedback, or it tends to be only the negative feedback that you see.
That's right. That's right. And it's so much fun to just do these types of things in the community. You know, a lot of people, I don't know how they perceive you. I feel like a lot of people perceive me as like this super expert because I'm interviewing these people who are really well known or have built, you know, like here's a person who built Flask, or here's the person that built this feature or whatever. The way I perceive it, it's more like I'm the first person who gets to learn about the stuff that I get to cover, you know, and then I just end up sharing that experience with everyone else later.
Yeah, exactly. That's even more for me, I would say, because the idea of this podcast is really, as the name says, to learn Bayesian statistics. And it's not only for my listeners, it's for me too. And most of the time when I interview guests, I discovered the topic they are talking about. And most of the time they are really experts in the topic. So I'm really the first one to mess up when I interview them, you know, so always on the spot.
Yeah, absolutely. That's the trick, is you just find interesting people and you just genuinely talk to them. And then that's all you got to do, right? You don't have to be an expert, at least to not get started, right? You almost can't help it over time if you talk to all these great people doing so many amazing things. But yeah, a lot of fun.
Yeah, that's true. And actually, thank you again for your podcast, because it's actually a show that really helped me and influenced me to start this very podcast. And I think you'll see the influence you had in some of the questions, particularly at the end.
Oh, you're very welcome. I remember when you reached out to me and said that you were doing ask a couple of pieces of advice, and it's really great to see you still going strong and doing the podcast. Congrats.
Yeah, thanks. As I often say to my fiance when she complains that I'm too nerdy, I often say that it's all because of you. So
I don't know if I should say you're welcome or apologize, but yeah, it's great.
No, it's great. I love that. No, and as you say, yeah, it must be also interesting for you to have feedback on your courses because you do video courses. So for you, it's even more important to have people get back to you because otherwise you really don't see your audience. And I guess that when you did some professional training in companies and so on, you had the reaction of the audience to adjust and to see what you were doing. But I guess when you do video courses, it's even harder.
It is harder. I think a little bit of public speaking is very valuable for almost anyone in our industry because on one hand, if you want to really understand something, you learn how to teach it, right? So you've got to just dig in at a level that you normally wouldn't have to. But then on the other, you also get to see how people receive the ideas and first process them, right? So I had a lot of different experiences that I think made it much better for me to create these sort of no feedback type of situations. The podcast is a little bit like that. The courses are like that. But I taught like the different levels of calculus and linear algebra and things like that at university to undergraduate college students, and then went on to do the professional development training like you're talking about for many years. And, I spent a long time standing up in front of people I would say something, they would look at me really weird, or they're like, yeah, no, that's not making any sense. And so, if you do that for a while, even when you're doing stuff that doesn't really have a direct audience, like YouTube videos or online courses or whatever, you still in the back of your mind have those memories of these people. They want to understand you. They want to learn from you, but they're not, right? So you're like, all right, what would I do to help that person now, right? I think that experience is really valuable. People can get out, do a little teaching or a little public speaking. I think it will help a long way.
Yeah, that's true. I think that's very true. I don't have your experience, but I guess it really helps. And actually, you handed me over a perfect segue to talk about your background, because from what I understood, you studied mathematics and you even have a PhD in mathematics.
Yes, almost. I didn't finish my PhD. I worked on it for 3 years and then I decided I'd rather do programming. My PhD program is where I was teaching those courses. I don't know how it is in Europe, but in the United States, it's glorious to be in computer science or mathematics or physics because many of the universities will pay for your tuition and then they will pay you living wage plus health insurance to teach like 8 hours a week or something.
Really?
And so it's a really good trade-off that you can basically work your way through graduate school by teaching. And like I said, I think it's a really valuable experience anyway. So yeah, that's how I got that. I worked on my math degree. This has been a problem for me all of my life. I've never really super clearly known I want to work on this. I was always jealous of the people who would say things like when they're in middle school, I want to study political science and make this change in the world, or I want to be a physicist and discover a black hole. Like I was always just curious, but never focused. So I kind of went around different topics in my math PhD program, but what I ended up doing a lot was working on computational stuff and visualization stuff because I was really good with computers. At the beginning, I wasn't really good at programming, but I was good at like figuring it out if I had to. So I taught myself C++ and things like that. And the more I did that, the more I realized math is cool and PhDs are cool, but if I go through and I really do important work in my PhD, what's going to happen is there's probably going to be like 10 people in the world who care what I've done. Like how much of an impact is that really going to make, right? It's not like you're discovering differential calculus and you're creating that, or like statistics, or, a lot of the really high-end math stuff is very, very specialized. And the more I did programming, the more I realized like I could actually have stuff that I'm really enjoying and make a much broader impact by working in software. And so that's what I did.
Yeah, that's super interesting. And actually, you said that you were used to programming. When did you start programming? Since you were a toddler or
Seems reasonable, right? I always loved computers, but not so much from a programming side of things. Like I love to go on the internet. When I say the internet, I had to dial up the internet and there was no web. There was like Telnet and there was Gopher and there was other like weird text-based ways. I think even before possibly email, but definitely before the web, which was like 1993. I was already in college then. So I took, I think, C++ when I was in college. college and I took Scheme, which is a derivative of Lisp, so I could get computer language credit out. But I didn't really start programming like genuinely until my senior year of college. And it was because of math. We were working on this complex dynamical system, which is like chaos theory in 4 dimensions, fractals in 4 dimensions, imaginary numbers, basically. And we were trying to visually understand some stuff. So they're like, hey, you want to figure out how to do that with C++? I'm like, well, I guess so. I took one course on it. We could try. And I just really loved it. And I'm like, why haven't I not done more of this? This is so fun. So that's really how I got started. I haven't been doing it for a long time.
Yeah, I think in your podcast in Talk Python, often I am quite impressed by the fact that a lot of guests actually started programming when they were children, like,
yes,
oh yeah,
I
I started programming when I was 6 or 7 or something like that. And I'm like, what?
Yeah, I learned to read by reading C++. Yeah, stuff like that, right?
Exactly. Yeah. For me, the quotes are for documentation, not for a normal quote.
Not for language education.
Yeah, exactly. Yeah, it's actually reassuring, I think, for listeners. Yeah, actually, would you say that no matter at what age you start learning programming, you can do really something interesting with it and even find a job in whatever field you like involving programming?
I think so. I think that's a pretty fair statement. I mean, there probably is some upper bound on the age, but that's probably like 75 where you just don't want to work anymore at all. So like you're not going to get into it, right? I think there's also different expectations of becoming a programmer. So I think the traditional understanding of being a programmer is not exactly where things are. And, we're going to talk about Python and its community and its growth and stuff like that. And I think these all tie together. The traditional understanding of programming is I'm really good at programming. I could build Windows, I could build Office, I could build Chrome, I could build Node, whatever I need to do. I'm super a programmer and I'm going to go around from place to place and understand the software they need to build. I'm going to build that for them, right? And those people exist mostly, and they're important. But I think where the real value of programming is in going from 0 to 30%, not 97 to 99% capable. And what I mean by that is like everybody has something that they're into, that they have experience with. And, I often refer to this as programming as a superpower, right? Like if you care about economics and you're not a programmer, you're stuck with using Excel the best you can to answer the questions. But all of a sudden, if you have like 10 lines of Python code, you can go and do some web scraping, you can pull some stuff down, get live data that's constantly updated. You gathered it from every government on earth. Automatically almost, right? It unlocks like a huge differential. So when you ask like, is it too late to learn programming? It depends what's your goal, right? Are you going to create the thing that is the next mobile operating system? Or are you going to take your skills and just amplify them 10 times more powerful with code? It might be tricky to do the operating system stuff at some point, but I think the amplifying the superpower side, everyone can do it. It's no big deal. Also, another interesting thing that people believe that I think is especially interesting for your audience is people think you have to be good at math to be a programmer. And within your world, that may actually be true to some degree because you guys are very focused on the data science side of things, which is based on math. But much of programming, the level of math you have to have is so small. But for some reason, at least in the US, the thinking is like, oh, you got to be really good at math, right? Like you better be good at calculus. It's like, I haven't used calculus in a program for 15 years. I did some stuff. I did wavelet decomposition and I did a bunch of interesting analysis when I was working at a scientific company. But the most bit of programming, it's like maybe basic algebra, maybe, you know what I mean? It's not a lot, right? I don't think it's too late. I mean, anyone can have something they're passionate about, learn a simple language like Python, use some of the really impressive libraries, and put something together that will make a significant difference in that thing they care about.
That's resonating with my experience, at least because I remember that I built this pyramid web app, actually, thanks to one of your courses.
Oh, yeah. Awesome.
And this web app, I use it to showcase some model I do for political election forecasting in France. And before I learned Python, I went on pollsters' websites by hand and I gathered the polls by hand in an Excel spreadsheet. And it was so painful and not at all interesting, to do that. And I remember one of my first programs was to automate this process. And so, as you said, to write web scraper that would go on the internet and scrape the most recent polls and then refresh them and clean them with pandas and so on, and then run the model. And when just the fact of launching your program and seeing it come back in like 5 seconds later with all the polls.
That's awesome.
Like, you're like, man, I mean, my life has changed forever now.
Yeah, there's so many things that are interesting questions or interesting things you'd like to know, but that's going to take a whole day. And it's not worth a whole day me working on it. But is it worth 2 hours or maybe a whole day once? And then it's just automatic continuously for the rest of your life, right? You just build up these little things. Like in my life, I have all these little programs that help run my business or my podcast or whatever. There were some points where I thought, I'm going to have to hire somebody to do this X thing because it is just taking away too much of my time and I keep making mistakes. And then I'm like, wait a minute, what if I could write a program to do this? Not that I don't want to hire people or work with people or whatever, but I could just put it into code, push a button, and then the answer comes out 100% reliable very quickly. All of a sudden, that thing that used to be hard now becomes just something that happens automatically in the background. It's crazy.
Yeah, exactly. That's really great. Actually, when you think like that, it helps you become more independent and more having a can-do attitude because you're like, okay, this thing is really painful and boring. I should try to automate it. And then you come back with a program that helps you save dozens of hours and that's creative. And then you can either enjoy a coffee or work on a model while your program runs or stuff like that.
That's right. And, people have asked me, well, if I'm going to get started with this idea, I'm going to write a little program to automate something in my life, right? You don't want to try to say, well, I'm going to do everything with code because that's a huge problem, right? There's parts where people are really important, but there's also parts that are super boring, like you said. And the way I think about it is, what is the thing that makes me most unhappy or is the most tedious and boring that I have to do all day, Because usually tedious and boring is very repetitious and it's not too hard to write a program to do it. And you really don't want to do it. It's not like, oh, I really enjoyed writing those articles, but now the AI writes them, right? Not that kind of stuff. It's like, I really hated copying the numbers from this spreadsheet over to that spreadsheet all the time. Now I just push a button and it's done. You know what I mean? That kind of stuff is really the low-hanging fruit that people can go and find ways to just make their life better and they can go work on what they actually care about.
Yeah, exactly. Well, I could talk about that topic for hours, but unfortunately we have to move on.
Yeah,
but
for sure.
I'd encourage listeners to go and listen to your podcast. There are plenty of episodes where you have guests talking about these kinds of projects. It's usually really enlightening.
Yeah, thank you. I love to tell stories like this because it's one thing to speak to hardcore programmers who I consider myself one of them, right? Those are my people. But I think it's even more important to tell stories about how programming is empowering much broader adoption of these ideas. There's some great ones from philosophy or escaping Excel or all these different things that would be really valuable.
Yeah, exactly. And actually also talking about what most people are doing in their everyday life with Python or data science instead of only the biggest and the greatest core developers that do so amazing things, but that are not representative of what most people do.
Yeah, absolutely.
Okay, I want to switch to Python now, but before I have to ask you this question because even though this show is a little special and not as centered on Bayesian methods as usual, actually I think it's the first time we're saying the word Bayesian in this episode. That's really unusual.
Yeah, you're breaking the mold. We've talked for a while and you haven't even gotten to it.
Exactly. But I have to ask you because you did, as you said, you studied math for a long time. So I wonder if you were introduced to Bayesian statistics during your math studies.
Not a lot. I did some statistics while I was there. My focus was really on calculus side of things. So real analysis, complex analysis, that kind of computational proof stuff. So sadly, not as much. I wish that I had because it's making a huge comeback, especially in the Python space. It's really taking off there.
Yeah, exactly. It's quite amazing to see all this space bubbling up with ideas and frameworks and new algorithms. I guess you have a conceptual understanding of the concept, but you're not on this side of Python.
No, I'm sorry. When I'm working on Python, I'm either in sort of the web database online side, API side, or I'm in the automate the boring stuff side of things. You know what I mean? Which we just described, right? Like all these little programs that just like run my life. And whatnot. So yeah, data science is super interesting to me and I'd love to get more into it. And I'm actually working on a couple projects. I feel like the right place to start is to go create a Jupyter notebook and that's a special place for me. That's going to be different. So it'll be great.
Yeah, exactly. I love Jupyter notebooks. Jupyter Lab is really my buddy of every day, so...
Yeah, I was just looking at a couple of cool things, cool extensions around there. Like, have you heard of Jup Text? Jupy text?
I don't think so.
So it lets you export Jupyter notebooks as either Markdown or Python scripts or even MATLAB scripts, all sorts of different interesting things. So it's pretty cool. There's just so much happening in that space right now.
Yeah, that's actually useful because when you put a model in production, usually you want to transfer your code that's in a Jupyter notebook into a Python script. So it's really useful.
Right, exactly. So that's a quick way to do it. Could get started at least, yeah.
But as you say, Jupyter is so awesome. Each time I have to work on a project where I have to use Jupyter or even Python at work, I'm like, ooh, great. It's going to be a great day.
It's a good day. It's a good day. It starts with the Jupyter Space Lab. Let's go.
Exactly. Yeah, actually, I'm feeling the same as you do about Python and data science, but for web dev. I'm like,
Nice.
Man, there is so many amazing things going on in web development for Python. Well, I don't have time to go and try all these new stuff that look really amazing.
Yeah, it's exciting on both sides. And I think that touches on one of the key elements to really be successful is if you have a project that you're working on that needs a thing, it's easy to learn. I mean, not easy, but it's like, well, I'm just going to work on my project. And when I'm done, I'm going to have this great experience, right? But if you don't have a project, like I really would like to work with the visualization stuff more, but I just don't have a lot of stuff I need to visualize that much, So I can certainly see areas where it's worthwhile, but I'm not sure it's worthwhile to put all the effort, right? So if you don't have a project, it's like, well, it's super interesting, but it's hard to really dive into it,
Yeah. And actually, it makes me wonder, is it why Python became your favorite language in the end? Because it's easy to pick up? And also, do you remember how you first got introduced to Python?
I do. I was working with a couple of different technologies for a long time. I did a lot of C++ programming. I talked about how that's basically how I got into programming for real. And then I did a lot of .NET and C# for a long time. And after a while, I just, this is great and all, but I would really like to expand my world, have a little variety, partly for career sake, right? Like the popularity of one technology goes down and you're only good at that. Well, that's a problem, right? Like I had a friend who only worked on AS400s and that's all they programmed. And those things are not even made anymore. They still need programming, but it's smaller and smaller and it's more maintenance. You just don't want to be like sucked down that path if you don't have to. So I'm like, all right, well, I'm going to go learn something new. Let me look around and see what people are raving about. Actually, a couple of friends were all into Python and I'd go talk like, what are you doing with this? Like, what are you building this with? Oh, this is Python. It's so amazing. And I talked to someone else. What are you building with this? Oh, I'm doing this with Python. It's so cool. Let me show you. All right, there's something about this Python thing. Let me go check this out, right? And as I worked with it after a few weeks, this is a really, really cool technology. Obviously, I knew JavaScript because I'd done web stuff. People were so excited about Node. I'm still not excited about Node today. It's fine. You could use it for whatever. I have plenty of JavaScript on my websites that I got to write and whatnot, and it's fine. But it doesn't make me go, wow, I really want to get into this. But when I started to learn Python, it was really intriguing. And the more I learned about it, just the more amazing it became. I was kind of looking for a new technology to just round things out and have a different perspective. And as I got into it, my intention wasn't like, oh, I'm going to drop all this other stuff I'm doing and just jump into Python. But I'm like, let's put that other stuff away for a while because this is super cool. Let me figure out what I can do with this over here. And I really got into Python and just loved it pretty much from the start. There's always growing pains when you change a technology. Yeah. It's just kind of frustrating because you were really good at something like, oh, I need to parse a JSON file or I need to talk to a database or whatever. You could just do it cold. You don't have to look up anything. You just know exactly how to do it, what the trade-offs are. And you go to a new technology and you're like, I bet you can do it here, but how? Right. So there's always that little bit of transition challenge, but it just seemed like such a great place to be in. I decided, I'm going to move over here for a while, see what it's like. And I've never looked back.
Yeah, that's great. Actually, because I guess the answer is going to be different from what you just said that attracted you to Python because you were kind of already well-versed into programming and you could program in C++. So.
Right, exactly. And I think that's interesting because a lot of people who are attracted to Python is not for that reason. It's exactly because they're not programmers, right?
Exactly. That was what I was going to ask you is when you talk to people who are non-programmers, what's the distinctive features you give them? What's the elevator pitch for Python you tell them?
Well, I think there's two parts of it. I think there's the reason that people come, and then I think there's the elevator pitch. So I'll give you the elevator pitch first. They're related. So the elevator pitch for me. This is the term I'm trying to define for the world. I don't know if it exists, but my description or my elevator pitch is that Python is a full spectrum language. What I mean by that is I started in C++. C++ lets you build amazing things. The Unreal game engine, Windows, Linux, Chrome. But you know what it doesn't let you do? It doesn't let you get started easy. Oh no. There's lib files for related DLLs. There's types. There's pointers. There's compilation. There's linking. There's a lot of real programming in like air quotes for just to get started, right? And if you have something simple to do, it's overkill. And not just overkill and like, okay, I've got to get my mind around pointers and malloc and new and whatnot. But even once you get the concepts down, there's just many more lines of code you have to write in a language like C++ than you do in Python to accomplish the same thing, right? The data structures in Python are just better, smoother. It's just easier, okay? So it's not just hard to get started with C++, but it's kind of inefficient to do simple things relative to, say, something like Python. But you can do amazing things. So C++ would not be a full spectrum language because it's hard on the low end of the spectrum. It's hard to get started, but it's great on the high end. Other languages like Visual Basic are cool. You can build these little GUI things and draggy droppy stuff around, and that's cool. And you get really started. But at some point, you get to a point like, okay, we're going to build a real app now. So we're going to convert this over to some other language. Visual Basic's easy on the low end, but it hits a upper bound, a ceiling really quickly. And Python is unique amongst many of the languages in that it is basically as simple as it can possibly be for you to get started. You create a file, you put the words you want in there. They don't even have to be in a function, right? I'm going to load this file. I'm going to sort this data. Then I'm going to plot it in matplotlib. Boom, right? Just like that. And yet, YouTube is built with Python. Instagram is built with Python. All these incredible systems, Jupyter is built with Python. It lets you sort of start with the minimum number of computer science concepts that you need. But as your program gets more complex, you can bring in things like generators and classes and inheritance, ORMs, and you name what it is that you need, and it can get brought in. But the thing that's special about Python is it doesn't make you bring them in the beginning. It's only when you need them. And I think that's the elevator pitch for Python. It's super special in that regard. Plus, it has PyPI with all the libraries that you can bring in.
Yeah, that's true. And actually, because you already talked to him, but do you know if Guido van Rossum had this goal in mind when he first started developing Python, or is it like just a happy coincidence?
Well, my guess is it's probably a really sweet coincidence. I think Python started more on the low end side of things, not in a derogatory way, but I think it's derived off of his experience with the ABC programming language, which I believe was a teaching language, not like a build production enterprise grade applications language. So its origins are in that, like getting started simple. Certainly credit goes to him for adding the right features, right? Adding generators and adding classes and adding like the right things along the way. But also a lot of the credit, I think, goes just to the community and the core developers, because Guido did a ton of work to get things rolling, but then a whole bunch of stuff has been done by folks who are just core developers who are not named Guido.
Yeah. That's a very interesting thing to think about.
Yeah. So the other side of the question you asked was about sort of why people who are not necessarily programmers get attracted to Python. I think they accidentally fall into Python a little bit. They have a problem. I've got a data set. I want to load this up and I want to just filter these or fix this data or print this out. And I could use MATLAB or I could use some other simple language. But hey, Python is really simple and it has this cool library that already understands my format. So I'm going to do that. And then that's working for them. Maybe they're a biologist or whatever. And that little thing they did was working, but they need a little more complex. So they bring in a little bit more of the language and it's a little more complex and they bring a little more of the language. And all of a sudden they're like, oh, wait, I'm actually a data scientist. What just happened? So I think when you ask about how a lot of people get introduced to Python, I think they have these really mild, simple goals. Python is one of the options they could choose, but they never have to leave, right? Like if you chose SAS or you chose MATLAB, you have to leave at some point because, well, it was great to look at this graph, but now I want a live dashboard on the web. Can't do that anymore. So now I got to rewrite it. What am I going to rewrite it in? Node and JavaScript? Maybe. I don't know, right? But they have to leave where they started. And because Python is this full spectrum language, you never have to leave. So it's kind of like a black hole. Like once you get sucked in, you're just kind of stuck there because there's nothing to eject you back out because they're like, well, I can just keep working here. This is great. People are friendly. Libraries are awesome. Let's just keep rolling.
Yeah. Exactly. That's a really good description I think of most people, and it's actually what happened to me. I mean, I was first doing my project in Stata and a website on WordPress, but I wanted to automate everything because it was too long, as I said earlier. And then a very good friend of mine actually told me, oh, you should try to do that on Python. Well, to learn Python, there is this really nice course done by Michael Kennedy.
Oh, nice.
Yeah. And so, I actually, to do that, I was like, oh yeah, let's build the website in Python and do the models in Python too, so that I can automate everything. At the beginning, I was mostly working on scikit-learn, but well, I'd like to go into the Bayesian framework because what's important to me is the estimation uncertainty, and you get that for free in the Bayesian framework. So, well, there is this great library called PyMC3. So, well, let's do that. And as you said, you can do everything you wanted to in Python.
Yeah, the more I think about it, the more I sort of see it as a black hole, right? Like once you get sucked in, there's just no reason to get kicked out of it. It's like you're stuck there because there's just so much gravity and stuff that's working for you there.
Yeah, exactly. Actually, something I often hear is that data science and machine learning are a big reason why Python continues to grow year after year. So I wonder what you think about that assessment. Also, I wonder why do you think Python came to play such a role in data science and statistics? Because at the beginning, it's really not a language to do that.
Yeah, in the beginning, it was all about R and other languages like that, right, Julia? I think it comes back to this idea of why people get into it. When you talk about data scientists, it's easy to think, kind of like I talked about the super programmer, right, that could go create the next Android or whatever. When people talk about data scientists, I get the sense that what they mean is like, oh, here's this person who has like complete command of like deep learning, computer vision, definitely Jupyter and the visualization stuff, and probably really good at math too, right? Like all these things. And I think that's the data science conception of the person who's like this super programmer. But what I think actually the growth around data science means, I mean, there's definitely legitimate growth around machine learning and legitimate growth around computer vision and whatnot. But I think a lot of the growth is people coming in, not first thinking of themselves as data scientists, but just people who are either scientists or studying something who have like a computational problem to solve. Like I'm an economist and I need to study all this data. Well, I'm not a programmer, but I need to work on this data somehow, and I'm tired of paying for MATLAB or whatever. I've heard there's a cool library in Python that'll let me skip a huge bunch of these steps. So I'm going to just try it over there. And so they have a computational problem that would sort of be encapsulated in the data science sphere, but they don't consider themselves to be data scientists. And they didn't go into it to become a data scientist. They went into the tools of data science to solve their simple problem. And then kind of like me, they get sucked into, hey, I really like this programming thing, right? I think the growth around data science is really strongly fueled. I'm not sure I'd say mostly fueled, but it's strongly fueled by all these people who have standard computational problems. And then they find Python solving that. And they just do a little more and a little more. And then they're like, oh my gosh, I think I might be a data scientist. Just to give you a concrete example, there's a company called Kroger, which is like one of the biggest grocery stores in America. And the company is at 8451.com. So this is the data science side of Kroger, who owns all these grocery stores, basically. And they have all these people shopping and doing stuff. And they actually have 200 full-time data scientists working for them. And many of them are working with Python and many of them are working with R. And so I talked to those folks and they said the most common degree that our data scientists have is economics, not computer science, not statistics, not mathematics, economics.
Ah, yeah, that's funny.
That's crazy, right? But there it is. And so I think that's kind of an example of there's a bunch of people coming into programming. They've got a computational problem. There's a bunch of cool libraries in Python. It's easy to do it. You can visualize it well. And so they get sucked in. So when you say that the growth of Python is powered by data science, I do think it's true that like that side of the sphere is definitely growing. If you look at the surveys of like the PSF and JetBrains survey, basically it was 50-50 split. About half the people are on the website, half the people are on the data science side. And then there's like a little slice that's just other, but those are the two main parts and they're basically equal. But I think it's a lot of people are coming in from these other disciplines and finding Python to be their superpower. And then they're just doing more and more over there. right? They're using data science as the way to like study their area. What do you think about that, right? You're on the other side of the fence more than me in that.
Well, actually, I'm a little disappointed because I don't have much to disagree with you. No, kidding aside, I agree with that fact, and it's tied to what you said about Python being a full spectrum language. To go back to the friend of mine I was talking about earlier, when he introduced Python to me, I remember he told me that what's great with Python is that it's the second best language in basically everything. So
That's right.
which is a little like the same idea as your full spectrum idea, but I think full spectrum is maybe a better definition because it can be two-dimensional, you know.
I like the full spectrum one a little bit better. I've heard that quote and I do kind of like it, although I think in some ways it's one of the really best languages for a lot of problems. It's really good at it. But I like the full spectrum in that it like expresses this natural tension. It's really just hard to have a language that is both good for building enterprise scale, high performance stuff, and that economists can decide is a good place to start, right? And so I think it's kind of special that way. I can't really think of anything else. Like JavaScript kind of used to be that way, but JavaScript's hard now. There's a lot of stuff going on with the JavaScript frameworks, and you got to know CLI stuff to like generate the starter stuff. It's not easy like it used to be. Not saying it's necessarily bad, but it's not super simple like it used to be.
Exactly. Well, just an example about that. With JavaScript, I always dreaded having to do some JavaScript for my website because I use a lot interactive plots and so on. And like in the years since 2017, I mean, we had Bokeh come in. There is also Plotly, and these are amazing libraries that basically abstract the JavaScript layer away from you, and you can program your plots in Python and they become interactive plots. So that's just awesome. And I use that for my website. Well, just as you say, I can do that with Python too now, while it was kind of hard, I think, to do that, I don't know, in 2014 or 2015, something like that.
It's really getting much nicer. Those are great libraries. Yeah. I love how they take all the stuff that you would have to write in JavaScript and just sort of, now you just talk to it like this and it looks interactive and beautiful. It's great.
Yeah, exactly. Yeah, there is this part. And also, as you said, it's really painful to change from one language to another because first, of course, at the beginning, you have to lose some time to train yourself to the new language and so on. So I really think people everywhere and whatever the language they code in have a very strong incentive not to change and not to try something else.
Yeah, something has to work badly. Yeah. It has to not work for them a lot, right? Or the other thing they could trade to has to be a lot better. It can't just be a little bit better, because I also think this is especially strong for people who are not programmers. Because if you study computer science, you've done 3 or 4 languages in college, and then you probably worked in something else. So what's a 6th language? Fine, we'll go learn that if I need to, right? I'll learn Go because I already did C++ and C and such, and you know what I mean? But if you are a biologist and you taught yourself Python, you're not going to go, well, maybe it's time to stop that and go to C++, right? You got to have a strong reason to do that, because you don't probably consider yourself at your core a developer that learns all these languages. You're a biologist who happens to have like this data science power.
Yeah, exactly. And also when you're in that position, the fact of knowing yet another language is not really important, and you're not really rewarded for that. Whereas the programmer who learns another language will be rewarded for that, either in his job or in his new job. So you have an incentive to be efficient. I think a big part of Python's growth is due to this fact that you don't have to get out of the Python ecosystem to find something that suits your need and that's really great, as you said.
Yeah. And every day that's more true. I was working on a course where I was talking about PyPI, and I took a screenshot of it, and I'd written all the materials. And by the time I'd gotten to record that chapter, it'd been like a month. And the screenshot, it had 206,000 libraries that you could use. And I pulled it back up like, well, this is out of date. It's 215,000 a month later. There's just more and more polished stuff and more ideas that you can just go grab.
Yeah, exactly. It's network effects in the end, and the rich get richer.
Yeah. Exactly.
But in that case, it's quite nice. Actually, I'm wondering, what do you think will happen in the future? I mean, do you think Python will stay as important in statistics as in programming as today? Or do you think one of these 2 pillars will migrate to something else?
Well, I think if a pillar is going to migrate, and I'm not saying that it will, but if one is going to migrate, it's not going to be data science. It's going to be the web. There's more legitimate competition for the options there in the web than there is in data science. I mean, there are other options, obviously. There's R, there's MATLAB even, and there's stuff that people could go to. But I think Python's advantage on the data science side is stronger than it is on the web side because you've got Node.js, you've got Java, like a lot of these other things. You got Ruby on Rails and whatnot. Like all these are focused exactly on the same problem and they've been around longer. So there's kind of these other strong communities as well. So if one of the pillars is going to shrink, I would say the website. That said, that's my favorite side. So I don't want that to happen. I think there's two things at play here. One of them is if you look at the growth of Python and you just talked about these network effects, it's a little bit like asking, is Facebook going to go away? It's possible. It's possible there's enough resentment of Facebook and people push back against it. MySpace went away. But at the same time, you can't just go start another social network that has like a better timeline or something. That's not going to make the difference, right? The problem is like all the people are there and putting their attention and their energy into a place like Facebook. So it's very hard to like break those network effects. And I think to some degree that's happening with Python. We see a ton of people moving there, migrating there, learning their first language there. We also see Python being used as a teaching language more and more and more. Right? In the United States, it's become the most popular first-year computer science course language. When I took computer science, I learned Scheme, which is a derivative of Lisp, which is a super painful language. I took this language, I'm like, okay, I'm sure I'm learning stuff here, but I will never work in this again unless I'm made to, right? Like that was my feeling about it, right? Whereas people are being, quote, forced to learn Python as part of their degrees, and their reaction most likely is not like, this is dreadful, right? It's probably, this is wonderful. Like, why do I have to worry about all these other problems of these other languages? So I think the network effects are strong. I think somewhere in France, there was like a big move to make Python part of the curriculum. Isn't that right?
Yeah, exactly. Actually, I was gonna say that. Yeah, in France now, in high school, people are taught Python. In high school, I didn't have any software education, but then I went to a really French way of studying, which is called a classe préparatoire, which is really weird. It's like you work really hard for 2 or 3 years, and then you have these very hard exams called concours. And then you go into what's the equivalent of what in the US you would call the Ivy League or something like that. It's like really big and all and prestigious grande école, which mean great schools.
Nice.
It's basically elite universities, And to do that, I remember part of our math curriculum was to learn Turbo Pascal, which is like a really, really old, and you don't use that in your everyday life, as a programmer. Now, some of the curriculum is in Python too. It's really amazing to see that happening.
Yeah, it's super amazing. And it's really, really valuable just as a skill. When I think of what the average person graduates high school with as skills that you could go get meaningful jobs, honestly, at least in the United States, I mean, high school is fine, but it's basically you're prepared for college or you're prepared for something that you didn't learn at high school. For the most part, there are these vocational apprenticeship type things. If you took a year of Python, you could reasonably do some kind of consulting or get a junior dev position or junior data science position with that skill, right? That's pretty awesome.
Yeah, that's great. Plus, it teaches you other skills like problem solving and stuff like that.
Yeah, I definitely think that there should be more room in the curriculum for these types of thinkings. I think there's a very outdated way of learning problem solving in school.
Yeah.
It sounds like France has made a good step there. And, it has all the trademarks of established industry organizations that are hard to dethrone. For example, one of the things that we study a lot when we're in middle school is geometry. If I have these 3 angles and I know this angle's like that, what can I say about angle C, right? Using my axioms. So you've got to think through, it's almost like miniature proofs. I got to think through, okay, I have these axioms of geometry and I have this set up so that I can derive this thing, then I can find that thing, then I do the next, right? That's really great problem solving thinking. And it's exactly the same type of thinking you have in programming. I have these library functions and I've got this problem. How do I arrange them with the language in such a way that I have YouTube or something? But the challenge is once you become really good at geometry, there's no use for it. You know what I mean? Like, not really. Maybe teaching, there's not a super applicable thing you can do with that, but it's trying to accomplish the same thing. So I don't know if you could do something like, say, you know what, geometry is interesting. Nobody needs to study angles that much. Let's put Python there or something like that. But obviously the math teachers who've become specialized in teaching geometry and they have all their lessons and their exams, they don't want to like reset their career to become programmer teachers. There's a lot of resistance in the establishment for that, but there's clear places where we could modernize this thought of problem solving with something like Python. It doesn't have to be Python, but some kind of programming skill that tries to teach you problem solving the same way that things like geometry do.
Exactly. I already heard you make this kind of controversial proposal in your podcast. I really like it. I think it's really interesting, and it resonates with also what I think and what I experienced. Because actually the problem with no Python being taught in high school in France is that most of the teachers don't know how to program in Python. So maybe you should come to France and give some courses.
It certainly is a challenge. And I think that's one of the challenges, right? The people who would have to teach it are not necessarily passionate about it or interested in learning it. That said, I know of a couple of high school teachers who are traditionally math teachers who have become very passionate about Python. There's a friend of mine, his son is in a college around here. His former math teacher, I guess he's probably graduated now, but she went and took some data science courses and some Python courses and listens to the podcast and whatnot. And now like the student assignments in high school are use deep learning to predict X with awesome. Python and Jupyter. I was just like, oh my gosh, that's awesome, right? It's just such a skill. And these projects that these high school kids are coming up with because this teacher took the effort to, just be curious and get started. It's crazy.
Yeah. That's true. I think for teaching statistics, it would be like really, really good because you could use random generators, in NumPy, then generate some numbers coming from any distribution you want, binomial, a Poisson, or a normal, and then you can visualize the distribution of these points and you can do whatever you want. So for teaching statistics and even regression, linear regression, it's even better. I remember my high school and later my studies, I learned statistics with pen and paper, and most of the time it was weird to me because I was like, I don't know why we spend so much time computing probabilities while computers are so better at it than us. We should spend our time doing intellectual things where we are better than computers. So thinking about models, thinking about causal relationships and visualizing the relations between the variable. And it's also a lot more concrete. So I guess it's easier to understand and also easier for students to relate to and to become passionate about this subject.
Yeah, it's harder to become passionate about it when it's just a bunch of cranking on numbers by hand. But if it was good enough for Gauss, maybe it was good enough for us now. I think that more kids would probably be excited about math and stuff if it was, here's an idea I can explore and here's an animation and I'm trying to understand what does it mean if I change this parameter or I change this type of, and you see it visually happening, right? It seems like that would be better. I guess probably the challenge has been if it's really hard to do the programming and most what happens is the kids just keep making mistakes and the code just crashes, then it doesn't make any sense, right? But we're getting to places where the tooling is so good, the visualizations are so good, and the languages are simple enough, libraries high level enough that you could be able to do it. I'm thinking of like Jupyter Notebook with like interactive widget thing where you can have some of those sliders that'll redraw the graphs and whatnot.
Yeah, exactly. Also having a concrete problem to solve is really the best way to learn programming. You would learn how to program while also learning about statistics also.
Yeah, I would have liked my homework more too.
Oh yeah, me too, definitely. Instead of computing combinatorics by pen and paper.
That's right. But you're right that having a concrete example definitely helps make those things more interesting. Yeah.
I know we're running a little short on time, so I really love this discussion, but I wanted to ask you about Python's weaknesses because I was wondering, what do you think Python should evolve to not become obsolete? What are its threats and weaknesses in your mind?
Well, it's a great language, but there are absolutely some weaknesses, but they might not be where people initially think. Let me take it from a contrarian perspective. A lot of people, when they first hear about Python or they think about Python, who come from older languages or something like that, they might think, or even, something like Go, which is not old or very popular, but it's fast. They might say, well, Python is slow, and that's going to be one of its problems. Like, we can't just keep building slow libraries. And the more slow stuff we build, but when you work with Python as a data scientist, you probably don't feel like Python is slow, I'm guessing. I mean, you ask it to do something and boom, it's super fast. So one of the reasons it's fast is it's got this cool combination, right? So like you might do something with pandas and NumPy, and yeah, you wrote your Python, but you handed off the data down to NumPy, and NumPy is actually C. So that's probably faster than languages like Java or .NET or whatever, right? So there's this interesting trade-off. But another even higher level way to think of that is if I have a problem to solve, like I'm one of these people who are like coming from a computational perspective, and my goal is to work on this for a while, and then I want the answer to come out. Right? If you spend 2 hours writing the program and then 10 minutes computing it, and out comes the answer, you spent half a day. If you spend a week writing it in C++ and debugging it, and then you get the answer to come out in 3 minutes, not 10 minutes, is it faster or slower? Right? Depends how you measure it, right? It took you a week plus 3 hours, right? It's a lot slower than half a day. There's like interesting trade-offs. And like, I think a lot of people see those types of things as the weaknesses of Python. Like, it doesn't have static types. So how can it be for real applications? Yet companies like JP Morgan Chase have 35 million lines of Python running their stuff, right? Like insane, important things. So I don't actually see those types of things as weaknesses. They can be tweaked and adjusted and whatnot. Where I think the weaknesses come more like missing where computation is happening. So Python runs on all the platforms really nicely, right? Windows, Mac, and Linux. It also runs on IoT things. There's amazing libraries or even frameworks, runtimes like MicroPython and CircuitPython, where you can have them on little tiny $5 microchips running Python. That's great. But, it's what's the story of Python on your phone? Can I build a mobile app with Python? Not really. I mean, there's Kivy. It works for a certain class of app and it lets you do that, but it's not the same as I'm using Xcode in the storyboard designer, and then I'm doing all this and I push a button and it goes to the App Store, or I'm using Kotlin and Google's Android Studio and so on. I think the threats to Python come not from these old school ways of thinking of like, oh yeah, C++ is faster than Python, so C++ is going to crush it. Like, that's not what has happened. But what could happen is people decide the most important platform I can build for is mobile. What can I use? I love Python, but it's out. So forget that. What else can I use now? That's the danger. The other one is talked about the web pillar. The other problem is there is a large move to build more front-end focused web applications, single page apps and that kind of thing, which I actually mostly dislike. I think people are dismissing having a server that does important stuff. I think they're dismissing the value of that to a large degree for various reasons, probably not worth going into on a non-web show, but I think those are perceived issues. And sometimes you need more interactivity, but a lot of times it's just like, well, I already know JavaScript, so I'm just going to keep up with that, right? So if you think of frameworks like Vue.js, AngularJS, React, even React Native, which will let you build like mobile apps, all of those things, Python is absent from those, right? You can't reasonably build front-end frameworks, front-end web applications that are mostly stuff on the browser plus some back-end services. You can't really do that in Python. And those are two super important areas of programming right now, mobile and front-end web.
Yeah. Exactly.
Another one is, let's suppose you build a really cool visualization exploration program and you can't share it on the web. It needs to run locally. How do you give that to someone who's not a programmer? That's not easy. Not easy at all. If I was building something in C++, I would hit compile and I would take the exe or the .app and I would give it to them. If I did this in Go, I would take the compiled app and I would give it to them. If I did it in .NET, I would press build. I would get the exe and I would give it to them. They'd have to be on Windows. I guess you could even ship the little .NET Core things these days. Like, you would give them the thing and they run it. There's not a reasonable, super good story in Python about distributing your applications to things and people who are not a server or developers. So those are the three problems that are threats and weaknesses. They're threats because they are weaknesses, right? I don't have a good story on mobile. For example, for the Talk Python training apps, those are written in C# and .NET on the Xamarin platform, because guess what? There's really good tools there. Like, I'd prefer to do it in Python, but I couldn't. I looked and I decided no. Then front-end frameworks, there's more possibilities and opportunities there with things like WebAssembly and then distributing it. I would love to see a focus of C Python itself to be how can we solve this distributed problem? Like if there was not a single new feature to the language, to a library, nothing for 2 years, and they said, but now I can type Python space build and out comes a .app or .exe, like that would be a game changer. But it's not, right? It could be. I mean, these are not like fatal weaknesses. They are present weaknesses. Like if you get that .app thing, you could probably compile it for mobile. There's possibilities, but they're challenging. I don't know. That's my thought. I'd like to hear what you think about these weaknesses.
That's super interesting. I mean, I wouldn't have thought about these, at least the last weakness, but the distribution issue, because I'm really not on this side of Python.
So what's so interesting is people say that to me, and I totally agree with you. They'll say like, this has never been a problem for me. I've never had a challenge of distributing the app to people because it's so badly broken that nobody even considers it a possibility to attempt it.
Yeah.
You know what I mean? It's like, I can't do this. It can't be done. If it was mostly working, people would go, there's this little thing that's not quite right. But when I distribute it to if I distribute it on Windows, it's great. But if I distribute it on Linux, there's a weakness. People don't even try to build those kinds of apps. Like I talked about Visual Basic, which builds these beautiful like UI things. You push a button and you get an exe and you double click it, pin it to your taskbar and you get a great UI. People don't even consider those types of apps within the realm of Python because it's so broken, which I think it's like almost this catch-22. It's like, it's so bad that nobody tries it. So nobody wants to make it better because everyone's avoiding it. Does that make sense?
Yeah, totally. Yeah, I really understand. And yeah, I was more saying that in the sense that I wouldn't even be really aware that there is a problem there because that's not really the type of things I'd use with Python. I mean, most of my difficulty outside of data science would be to distributing an app, as you say, but through a server.
Like a web app, like your Pulse web app,
exactly.
Right? And Python is glorious for that, right? It is very finely tuned for that. It works great. I would say no complaints there, right? But it's like, there's a lot of people building mobile apps.
Exactly.
And front-end JavaScript apps. Those are definitely threats. But on the other side, imagine Python had those three things covered. It's already dominating. What would it be like if it had those covered? You know what I mean?
Yeah. No, totally. Maybe I was also wondering if a threat or weakness could be that if the two pillars, the web dev side and the statistics side, began to diverge, and not really understand each other and having really different ways of implementing things, which would lead de facto to a situation where they use the same language, but it's as if they don't use the same language. And then maybe you would lose the full spectrum characteristic of Python that we were talking about earlier.
Sure, that's a really interesting thought. It's possible. I don't necessarily think that it's going to be a huge challenge, but it could be. With my teaching experience at the professional training experience, what was really surprising to me was in one 6-week period or something, I was teaching at an investment bank, like a hedge fund trading bank in New York City. I was teaching at a fairly secretive Air Force group in the desert. And I was teaching at a startup in San Francisco. And 80% of what they all needed to know, it was all the same. Like I could have just filmed myself in one place and replayed it to the other, right? There's a little differences around the edges, but it's really surprising to me how much more similar the programming problems are. And it's like, okay, here's what you got to do. What is your special area and how is it unique? And how do we have to embrace that? It blew me away how similar those three experiences were when I thought like, these are really different places I'm at,
Yeah, that's super interesting. Well, I have a ton more questions, but we're running short on time.
It's a good conversation. So. It's hard to keep it focused, right?
Yeah. I have too many questions for you. Well, maybe we'll do another special episode in some month.
Yeah, sure. We could do a follow-up. I'd be happy to.
Exactly. You've already been very generous with your time. So I just have one last question before asking you the two final questions. Because, well, you talked about these weaknesses and threats that you saw, but you're really well aware of what's going on in the Python world because you're very knowledgeable about that. But also you have this other podcast, Python Bytes. That's really great too.
Yeah.
By the way, I love it.
Thanks.
And congrats to you and Ryan Hawken on this one.
Yeah, we're having a lot of fun doing that show. We get to study so many new things.
Yeah, I bet. I can hear it when I hear you guys every week. So I was wondering if there are any advances that you see out there that are particularly exciting to you?
Yeah, I would say I feel like there's a lot of energy around new ideas in Python right now. And I think there's two things happening. One, Python 3 is making a lot of progress. So I'm thinking of things like type annotations, the async and await stuff to like bring more computational parallel sort of. It depends on where you put your computation, I guess, and things like that. So I think there's just a lot of people reimagining the way that things can happen on that side of things, right? We've got MyPyC, which will take type annotated Python code and compile it to native code to make it faster. Things like that, even Python, which is really relevant in the data science side. So I think there's just a lot of really new ideas that are growing on some of these foundations that have recently been laid. I also think the retirement of Python 2 is freeing people up to just go, okay, what's the modern way to do this, right? It used to be there was like a couple of web frameworks, Pyramid, Django, Flask, a couple of things. They kind of all did the same thing. Right now, like I'm losing track of how many frameworks there are because they're all trying to do something unique with what they have to work with now. Also, I think Jupyter is really blowing things up on the data science side, right? The visualization and the libraries, and it just seems to really be bringing in a lot of unique ideas. So I guess that's it. It's hard to put a finger on like exactly one thing because there's just so many things happening, but I feel like it's a time of wild creation. There's a lot of stuff that's getting created. Some of it's not going to be around in 5 years or it's going to go unsupported, but that's better than, well, we've always done it these two ways. So which one do you like?
Yeah, yeah, exactly. Yeah, there are a lot of awesome stuff happening right now.
Yeah, for sure.
Okay, Michael, I think we have to end it there, but definitely have to do a follow-up show.
All right, sounds good.
As you know, I stole one of your ideas in your show, which is to ask the guest the same two questions at the end of the show. And I really love this concept because from a statistician perspective, what's interesting to me is not any one particular answer, but the distribution of the answers.
Yes. Okay, great.
So the first one is, if you had unlimited time and resources, which problem would you try to solve?
So we're going to need a whole nother show for this one. To me, there's clearly one problem that is both a huge challenge and it is potentially the biggest challenge we're facing, but is also such a source of positive outcomes that I got to pick it. And that's solving climate change and transitioning our energy usage and our society to use renewable energy. You know, the consequences of failure are really bad, right? We don't want to have wildfires like we've had in Australia or other problems, you know, like 20 inches or whatever of rain in Houston. But it boggles my mind that this is even a problem, right? This is something that it seems so solvable. And I think this is why it's another show. It's like, I really wonder why would it be such a challenge? So like, I know there's a lot of folks who don't believe in climate change, too many, even though it's really definitely not the majority. But moving away from supporting dictatorial regimes to bring in energy into your country and depending upon them rather than just putting a black square to get some sunlight. Why would you want to bring those sort of societal challenges, right? It's just, if you had distributed energy that was lower cost, didn't pollute the world, that seems so important to me. And I think there's so many ways that we could do it. I think the technology is getting close. So I would love to work on that. Hopefully that answer is not too long.
No. It's really good, and it's definitely a very important issue, and actually a popular answer to this question. Quite some guests who answered climate change too, so awesome. I guess I can give you guys each other's contact information, and you can start start a task force.
Yeah, that's right. Just to me, it seems like if you were to solve it, even if put climate change aside, it's just the possibility of having all these different options for energy that don't require mining and whatnot. It just seems such a cool outcome for society. So anyway, you also solve climate change.
Yeah, exactly. And the second question, which is very easy usually for guests, is if you could have dinner with any great scientific mind, dead, alive, or fictional, who would it be?
This one was not easy for me. The first one was easier. I got to say, however, I do have an answer. I'm very fascinated with space. To me, I grew up in a place where I could go outside in the summer and look up, and there was very little light pollution. I could just see the stars and all the constellations, and would sit out with my friends and chat and watch the shooting stars, the meteorites go by. And so space has always fascinated me. And so the person I would choose would be Carl Sagan. I love his work on space. One of my favorite movies is Contact, which is a movie that he did with Jodie Foster. It was about SETI and like radio telescopes and stuff. So yeah, I definitely would love to spend some time talking to Carl Sagan.
Yeah. Awesome. Really good choice. And I think you're the first one to pick Carl Sagan on the show.
Right on. Well, another time maybe it would have been possible, but we're going to have to do time travel to make this one happen.
Yeah, exactly. Well, Michael, thank you. It was a real pleasure talking with you. They say don't meet your heroes, but everything went smoothly, so I'm quite glad.
Well, I'm absolutely honored, and that's quite a nice thing of you to say. And I really enjoyed talking with you. It's a lot of fun, and yeah, we could have gone on for hours, but we'll have to call it a show, right? Thanks for having me.
Unfortunately, we don't have unlimited time and resources, but I really wanted to thank you also for the important work you do for the community, and also for not being a dividing figure. You're always positive on Twitter and so on, and welcoming of feedback and beginners. And I think in a field where imposter syndrome is always lurking in the background, it's really important. And I'm sure you'll continue to help people train themselves to find work they love.
Well, thank you so much. It's an honor to get to do that, so I always enjoy it.
As always, I'll put resources and a link to your website in the show notes for those who want to dig deeper. And thank you again, Michael, for taking the time and being on this show.
Thanks for having me. Talk to you later.
This has been another episode of Learning Bayesian Statistics. Be sure to rate, review, and subscribe to the show on your favorite podcatcher, and visit learnbayesstats.anvil.app for more resources based on today's topics, as well as access to more episodes that will help you reach true Bayesian state of mind. That's learnbayesstats.anvil.app. Our theme music is Good Bayesian by Baba Brinkman, feat. MC Lars and Mega Ram. Check out his awesome work at bababrinkman.com. I'm your host, Alex Endora. You can follow me on Twitter at Alex_Endora, like the country. Thanks so much for listening. You're truly a
good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. Let me show you how to be a good Bayesian. Change calculations after taking fresh data in. Those predictions that your brain is making, let's get them on a solid foundation.